November 25, 2024, Douglas O'Regan releases Taking Nazi Technology with Johns Hopkins University Press. The title itself is shocking. America systematically stole German war technology. National Interest publishes on the same day. Did Nazi military technology make the US military into a superpower? But it was more than theft. It was the largest technology transfer in history. And at the center of it all stood one machine that changed everything: the V-2 turbopump. Developed in 1942, 58,000 horsepower from just 150 kilograms, a technological marvel that the Allies simply couldn't copy until they forced the German engineers to build it for them. Today, in 2025, every rocket engine on Earth utilizes the same fundamental principle. SpaceX's Raptor, the most powerful engine in the world, is based on German technology from 83 years ago. Blue Origin's BE-4, the engine powering the new Vulcan rocket, utilizes German design. Even Chinese and Russian rockets employ concepts developed at the Peenemünde Army Research Center in 1942. Wernher von Braun brought this technology to NASA. Today, we'll show you the documented technological lineage. From Hitler's vengeance weapon to modern spaceflight, a story of genius, war, and systematic technological appropriation. Picture this: October 3rd, 1942, Peenemünde, island of Usedom, the first successful V-2 launch, 84.5 kilometers in altitude. The first man-made object in space, but the revolutionary aspect wasn't the rocket itself. It was its heart, the turbopump, a device that everyone thought was impossible, a device that changed the physics of rocket propulsion forever. Technically, the problem was simple to understand, but impossible to solve. A V-2 rocket burns 9,000 kilograms of fuel in 60 seconds. That's 150 kilograms per second. Ethanol and liquid oxygen must be pumped into the combustion chamber at enormous pressure, 20 bar of pressure, at temperatures of minus 183 degrees Celsius for the oxygen. The turbopump has to deliver 150 kilograms of liquid per second at cryogenic temperatures at 30,000 revolutions per minute, 58,000 horsepower, from a machine weighing only 150 kilograms. In 1942, American engineers considered this propaganda, physically impossible, German exaggeration. They had reason to doubt. The best American turbopumps in 1942 produced maybe 500 horsepower at 5,000 revolutions per minute. With massive steel structures weighing tons, the V-2 turbopump was 100 times more powerful per kilogram. No Allied nation had anything even remotely comparable. How did this German marvel work? The physics were elegant, but the engineering was unprecedented. The turbopump was powered by a steam turbine. Hydrogen peroxide was catalytically decomposed by sodium permanganate. This generated superheated steam at 450 degrees Celsius. This steam drove a turbine, which in turn drove two pumps, one for ethanol, one for liquid oxygen. Two separate systems, precisely synchronized. The turbine rotated at 3,800 revolutions per minute, the pumps at 30,000 revolutions per minute, via a gearbox with an 8.1 ratio. But here's where it gets technically fascinating. The materials. At minus 183 degrees Celsius, normal metals become brittle. They break. The German metallurgists developed special alloys. For the oxygen pump, aluminum bronze that remained ductile even at cryogenic temperatures. For the bearings, specialized steels that wouldn't fail at 30,000 revolutions per minute. For the seals, graphite packings that could withstand both minus 183 degrees and plus 450 degrees. All in a machine weighing only 150 kilograms. The precision was astonishing. Tolerances were in the hundredths of a millimeter range. At 30,000 revolutions per minute, any imbalance would lead to immediate destruction. The German engineers developed specialized balancing procedures. Each turbopump was individually tested. Many exploded during the tests, but the ones that worked were technological masterpieces. Look at these numbers. The V-2 turbopump delivered 58 liters of ethanol and 74 liters of liquid oxygen per second. Together, 132 liters per second. That's 7,620 liters per minute. More than the entire tank volume of a modern passenger car in 3 seconds, with a pressure of 20 bar at 30,000 revolutions per minute, for 60 seconds of uninterrupted operation, without failure. And here is the crucial point that many overlook. The turbopump made large rockets possible in the first place. Before that, rockets were powered by pressurized gas. Nitrogen or helium was used to force the fuel into the combustion chamber, but that meant heavy pressure tanks. On a large rocket like the V-2, these pressure tanks would have weighed several tons, more than the entire payload of the rocket. The turbopump eliminated this problem. It weighed only 150 kilograms, but replaced pressure tanks that would have weighed 3,000 kilograms. That's why the Germans could build something in 1942 that the Americans thought was impossible. Not because German physics was different, but because German engineering was years ahead, years of development, millions of Reichsmarks in investment, thousands of engineers at the Peenemünde Army Research Center, and a relentless development process where hundreds of turbopumps exploded until one finally worked. Now comes the second act of the story. 1944, December. Allied intelligence begins collecting V-2 debris. In London, where the rockets were impacting. In Belgium, in the Netherlands, every fragment is shipped to Washington or London. Teams of engineers analyze them, and slowly the truth dawns on them. The Germans are technologically years ahead, not in everything, but in rocket technology definitely. The US War Department creates reports. Aberdeen, Proving Ground, Maryland begins systematic studies. British engineers in Farnborough do the same. They try to understand the turbopump. They measure the components. They analyze the metallurgy. They create blueprints. But there's one thing they can't do. They can't rebuild it. Not in 1944, not in 1945. Why not? The materials. American metallurgy in 1944 couldn't produce aluminum alloys that remained ductile at minus 183 degrees Celsius. British bearings couldn't survive 30,000 revolutions per minute. The balancing procedures weren't precise enough. Every attempt at an Allied turbopump ended in explosion. Sometimes at just 5,000 revolutions, sometimes at 8,000, never at 30,000. A report from Aberdeen Proving Ground, dated March 1945, summarizes it. The German turbopump represents a level of engineering we cannot currently match. Recommend acquisition of intact specimens and German engineering personnel for post-war evaluation. That wasn't an admission of defeat. That was cold, hard technical reality. The Germans had developed something the Americans simply couldn't replicate. So they had to bring the Germans themselves over. But before we get to Operation Paperclip, we need to understand just how advanced this Nazi-era technology really was. Because the V-2 turbopump wasn't just some isolated invention, it was part of an entire system, a system that made modern spaceflight even possible. The V-2 was the first large liquid-fueled rocket engine with a turbopump. But just look at the specs. The engine produced 25 tons of thrust. With a fuel consumption of 125 kilograms per second, that gives a specific impulse of about 200 seconds. Not impressive by today's standards, but in 1942, no other country even had a working, large, liquid-fueled engine. The combustion chamber was equally revolutionary. 18 fuel injectors arranged in a spiral. Each had to deliver precisely the right fuel-oxygen mix. The mixing ratio was critical, 1.224 parts oxygen to 1 part ethanol by weight. Too much oxygen. And the combustion chamber overheated. Too little. And the combustion was incomplete. The German engineers developed special injectors with swirling flow, guaranteeing the perfect mix. The cooling system was another masterpiece. The combustion chamber was regeneratively cooled, meaning the cold ethanol fuel first flowed through double-walled channels around the combustion chamber. This cooled the chamber and simultaneously heated the fuel. Two problems. With one solution, typically efficient German engineering. But the precision required for this was enormous. The cooling channels were only a few millimeters wide. With flame temperatures of 2,700 degrees Celsius on one side and minus 100 degrees Celsius ethanol on the other, any flaw in the design led to local burn-through, to the failure of the combustion chamber, to the explosion of the rocket. And yet, the V-2 engines worked, not always. Reliability was perhaps 70%, but 70% is impressive when you consider that each V-2 only flew once. No test flights, no debugging after the first launch. Each rocket was a prototype and a weapon at the same time, and 70% reached their target or came close enough. But now we get to the core. Why was the turbopump so revolutionary? Because it transformed the mass ratio. In rocketry, it's all physics. The Tsiolkovsky rocket equation is relentless. The final velocity depends on the natural logarithm of the ratio between the initial mass and the final mass. Every kilogram you save pays off exponentially. Pressure gas system, 3,000 kilograms for pressure tanks and gas. Turbopump system, 150 kilograms for the turbopump, plus 100 kilograms for hydrogen peroxide. Total, 250 kilograms instead of 3,000. That's 2,150 kilograms saved, with a V-2 launch mass of 12,500 kilograms. That's a difference of 22%. Without a turbopump, the V-2 might have had a range of 150 kilometers. With a turbopump, 320 kilometers. But that's not all. The turbopump enabled higher combustion chamber pressures. Higher pressure means more efficient combustion, higher specific impulse, better performance. The V-2, with its 20-bar combustion chamber pressure, was a world record in 1942. American engines had maybe 5 bar. Soviet engines maybe 3 bar. A fourfold advantage for the Germans, and here we see the technical superiority, documented in numbers. V-2 engine, developed in 1942, 25 tons of thrust, 3,800 kilograms weight, specific impulse 200 seconds, combustion chamber pressure 20 bar, American W8 Corporal engine, developed in 1945, 0.7 tons of thrust, 95 kilograms weight, specific impulse 195 seconds, combustion chamber pressure 8 bar. The German engine was 35 times more powerful. No comparison. But here comes the turning point. May 1945, Germany surrenders. American and Soviet troops reach Peenemünde Army Research Center. What they find exceeds their wildest dreams. Not just finished V-2 rockets, hundreds of them, partially disassembled, being evacuated south on trains. They find production facilities in Mittelwerk, Nordhausen. They find technical drawings, tons of documents, thousands of pages of detailed design plans, material specifications, test protocols, the entire accumulated knowledge base of 10 years of German rocket research. But most importantly, they find the engineers, Wernher von Braun, Walter Dornberger, hundreds of specialists, metallurgists who developed the special alloys, mechanical engineers who designed the turbopumps, test engineers who perfected the balancing procedures, people who knew how to build the impossible. The Americans were faster. Operation Overcast began as early as July 1945. Wernher von Braun and 126 German rocket experts were brought to the USA. Later, under Operation Paperclip, 1,600 more came. They were taken to Fort Bliss, Texas, to White Sands, New Mexico. There, they were to do for America what they had done for Germany, develop the future of rocket technology. The Soviets were slower, but more systematic. October 1946. Operation Osoaviakim, in a single night. 2,500 German engineers and their families were deported from the Soviet occupation zone. 6,000 people in total on trains to Russia. No one asked them. They woke up with NKVD officers at their door. They had 2 hours to pack. Then, off to the train, to Moscow, to Leningrad, to specialized research institutes, where they had to work for the Soviet Union. Both superpowers had the same goal: to exploit German technology for their own benefit. To exploit German expertise, and at the center of it all was the turbopump, because without a turbopump, no large rockets. Without large rockets, no intercontinental ballistic missiles. Without intercontinental ballistic missiles, no nuclear deterrence. Without nuclear deterrence, no superpower. The turbopump wasn't just technology, it was strategic power. And now the story gets interesting, because the Americans first tried to do it alone. They took the German drawings, they took the captured turbopumps, they took the material specifications, and they said, "We're America. We can build this too. We don't need the Germans to show us how." 1945 to 1952. 7 years of American attempts, project after project, millions of dollars invested. The best American engineers worked on it: Pratt & Whitney, General Electric, Rocketdyne. They all tried to build a turbopump that equaled the German one. They all failed. Why? The material, always the materials. American aluminum alloys became brittle at cryogenic temperatures. American bearings failed at high speeds. American seals couldn't withstand the temperature extremes. Test after test ended in explosion at 10,000 revolutions per minute, at 15,000, once at 18,000, never at 30,000. Aberdeen Proving Ground Report, November 1948. Despite 3 years of intensive development and expenditure of $12 million, we have not succeeded in replicating German turbopump performance. We recommend direct collaboration with German personnel. That was an admission. America, the ascending superpower, couldn't replicate what Germany had developed during the war, not in 3 years, not with 12 million Reichsmarks, not with their best engineers. So they brought Wernher von Braun and his team into the game. 1950, Huntsville, Alabama. The Redstone Arsenal became the new Peenemünde Army Research Center. German engineers worked directly with American engineers, not as teacher and student, but rather as master and apprentice. The Germans knew how. The Americans learned. 1952, finally. The first successful American turbopump that achieved V-2 performance. But look closely at WHO developed it. A team led by German engineers, with German metallurgy specifications, with German balancing procedures, with German testing protocols. It wasn't an American development. It was Nazi-era technology, reproduced in America, under German command, and from then on, everything, every American rocket, every engine, every turbopump was based on this German knowledge. But the story doesn't end in 1952, it continues to this day. To SpaceX, to Blue Origin, to every modern rocket engine on Earth, and this connection isn't abstract. It's documented, it's provable, it's technically traceable, and that's exactly what I'm going to show you now. The technological lineage, documented, provable, from 1942 to 2025, 1952, Redstone Arsenal, Huntsville. Wernher von Braun develops the Redstone rocket, the engine, a direct evolution of the V-2, the turbopump, based on German design. 30,000 revolutions per minute, the same special alloys, the same balancing procedures, but now with American resources, with American money, with American industry. The Redstone wasn't an American invention. It was a German rocket built in America. 1958, Jupiter rocket. Again, von Braun's team. Again, a turbopump based on V-2 principles. But bigger, more powerful. 135,000 horsepower, compared to 58,000 for the V-2. The technology scaled. The German engineers learned how to build larger versions, how to apply the basic principles to more powerful engines. But the real breakthrough came in the 1960s, the Apollo program. President Kennedy promises, "We will put a man on the moon." NASA says, "We need the biggest rocket ever built." And they go to one man, Wernher von Braun, the Saturn V. Let's look at the numbers. First stage, 5 F1 engines. Each F1 produces 680 tons of thrust. Together, 3,400 tons. The largest single-chamber rocket engines ever built, and the heart of each F1 engine, the turbopump, developed under von Braun's supervision, with principles from Peenemünde Army Research Center. With knowledge from 1942, the F1 turbopump is monstrous. It pumps 1,189 liters of kerosene and 2,578 liters of liquid oxygen per second. That's a total of 4,367 liters per second, 262,000 liters per minute, an Olympic swimming pool in 10 minutes, with 30 bar of pressure. At 500 revolutions per minute for the turbine, the pumps themselves rotate at variable speeds, optimized for maximum efficiency. But here's the crucial point. The F1 turbopump uses exactly the same basic concept as the V2. Steam turbine powered by catalytic decomposition. In the V2, it was hydrogen peroxide. In the F1, it's still hydrogen peroxide, but in a pre-burner system. The concept, identical. The execution, scaled, bigger, more powerful. But the basic physics, German. 1942, second stage Saturn V, 5 J2 engines. First, large rocket engines with liquid hydrogen and liquid oxygen, even more cryogenic, even more challenging. Liquid hydrogen at minus 253 degrees Celsius. The material challenges were immense, but the solution? German metallurgy, German balancing procedures, German sealing technology, all originally developed for the V2. From 1967 to 1973, the Saturn V flew 13 times. All 13 flights successful, 0 turbopump failures, 0. That's German reliability, German precision, German engineering pride, but built in America, for America, with German knowledge. Now let's jump to the present, 2015. SpaceX develops the Raptor engine. Elon Musk wants to go to Mars. He needs the most efficient rocket engine ever built. He needs full-flow staged combustion. That means all propellants go through turbopumps, are partially burned in pre-burners, power the turbines, and then are completely burned in the main combustion chamber. Maximum efficiency, maximum specific impulse. Raptor 2, the current 2023 version, 230 tons of thrust at sea level, combustion chamber pressure 300 bar, 15 times that of the V2, double that of the Space Shuttle main engine. The highest combustion chamber pressure ever achieved in a flight rocket engine. And what makes that possible? The turbopump. Look at the Raptor turbopump. Two separate systems. One for liquid oxygen, one for liquid methane. Each is powered by a pre-burner that partially burns fuel. The oxygen turbopump rotates at over 40,000 revolutions per minute, higher than the V-2. The methane turbopump at 30,000. Exactly the V-2 speed. Coincidence? No. Design. Optimal speed for that size and power? German engineers knew that in 1942. The materials, modern superalloys, Inconel, special steel alloys, but the concept, the same as German aluminum alloys in 1942. Materials that work at extreme temperatures, from -253 degrees for methane to plus 1,000 degrees in the pre-burners. The challenge is the same. The solutions have evolved, but the basic principles are identical. The bearings, ceramic ball bearings. But the balancing principle, exactly the same as in 1942, precision in the hundredths of a millimeter range. Any imbalance leads to vibration. Vibration leads to failure. At 40,000 revolutions per minute, there is no error tolerance. The German engineers knew that. SpaceX knows that. The physics haven't changed. Seals. Raptor uses labyrinth seals, complex geometric structures that force gas through narrow paths, reduce pressure, and minimize leakage. The V-2 utilized graphite seals, different technology, but the same principle, managing temperature extremes, controlling pressure gradients, preventing leakage. German, 1942, American, 2023. The same problems, further developed solutions. And now comes the documented proof. SpaceX publishes technical presentations. Elon Musk tweets details. Engineers give interviews, and you hear the same thing again and again. We studied Saturn V. We studied F1. We studied J2. We took the best concepts. We developed them further. But Saturn V was von Braun. F1 was von Braun. J2 was von Braun. Von Braun was V-2. The lineage is direct. V-2, 1942, to Saturn V, 1967, to Raptor, 2023, 3 generations, 81 years. A technological lineage. German in the beginning, German in the middle, German in concept, to this day. Blue Origin, Jeff Bezos's company. BE-4 engine for the Vulcan rocket. First flight in 2024, 2,400 kilonewtons of thrust, liquid methane and liquid oxygen, oxygen-rich staged combustion, a pre-burner for oxygen, turbopump powered by partial combustion. Sound familiar? It should. It's the same concept as the V-2, just with modern propellants. BE-4 turbopump, oxygen pump with 20,000 RPM, methane pump with 18,000. Combustion chamber pressure, 135 bar, not as high as Raptor, but still 6 times that of the V-2. And again, the basic concept is identical. Turbine powered by combustion, pumps move cryogenic liquids, extreme precision, German principles. 82 years later. Russia, RD-180 engine, developed in the 1990s, but based on Soviet engines from the 1960s. And the Soviet engines, developed by German engineers who were deported after Operation Ossoaviakim, Helmut Gröttrup, one of von Braun's colleagues at Peenemünde. He worked in the Soviet Union from 1946 to 1953. He developed the basis for Soviet rocket engines, his turbopump designs, V-2 derivatives, the RD-180 today, the great-grandchildren of Gröttrup's work, German DNA, in Russian technology, China, YF-100 engine for the Long March 5 rocket. Take a look at the specifications. Turbopump with 28,000 RPM, kerosene and liquid oxygen, staged combustion, combustion chamber pressure, 180 bar, the Chinese say, independent development, But look at the technical details. Look at the architecture. It is identical to Russian engines. The Russian engines are based on German technology. The technological lineage is clear. Japan, LE9 engine for the H-3 rocket, liquid hydrogen and liquid oxygen, turbopump with 25,000 RPM, expander bleed cycle, different from V-2, but the basic turbopump principles, the same. Moving cryogenic liquids, extreme speeds, precise balancing. The Japanese developed it themselves. But they studied American engines. American engines were German developed. The chain of knowledge is unbroken. India, Vickers engine for the GSLV rocket, directly licensed from France, French Viking engine. The Viking is based on American engines. American engines are based on German technology, so India indirectly uses German turbopump concepts from 1942. They might not know it, but the technology knows its origin. Even private companies, Rocket Lab, Rutherford engine, electrically powered turbopumps, not by combustion, completely different, right? Wrong. The turbopumps themselves move kerosene and liquid oxygen, the same cryogenic challenges, the same material problems, the same balancing requirements. The drive is electric, but the pumps are conceptually identical to the V-2, the same physical laws, the same engineering solutions. Relativity space, Aeon engine, 3D printed, modern additive manufacturing. But the turbopump? Still a turbine driving pumps, still cryogenic liquids, still 20,000 RPM, still precision balancing. The manufacturing method is new. The design concept is 83 years old. Now you see it, don't you? Every rocket engine on Earth, every turbopump, every cryogenic propellant system is based on concepts developed in Peenemünde in 1942. That's not an exaggeration. That's documented technical reality. The V-2 turbopump was so revolutionary, so far ahead of its time, that 83 years later, everyone is still using the same basic principles. Materials have improved. Superalloys replace aluminum bronze. Ceramic bearings replace steel bearings. Computer-controlled balancing replaces manual procedures. But the physics, the basic architecture, the concepts, German, 1942, Wernher von Braun and his team. And here is the uncomfortable truth, documented by Douglas O'Regan in Taking Nazi Technology. America did not develop this technology, not conquered in fair competition, stolen. Systematically, Operation Paperclip was technology theft on an industrial scale. 1,600 German scientists, tons of documents, hundreds of complete V-2 rockets. All the production equipment from Mittelwerk, all transported to America. The Soviets did the same thing. 2,500 German engineers, entire factories dismantled and shipped to Russia. German expertise forcibly recruited. For 10 years, some could never return. German technology formed the basis of Soviet spaceflight. Without German engineers, the Soviet Union would not have had Sputnik in 1957. Without German turbopumps, no R-7 rocket. Without the R-7, no Yuri Gagarin in space. America and the Soviet Union, the superpowers of the Cold War, built their rocket programs on German knowledge, on German technology, on German people who had no choice. Von Braun later said, "We wanted to go to the stars. We weren't interested in politics, but he had no choice. Work for America, or go to prison, maybe worse." So he worked, and America flew to the moon. With German technology, 2025, SpaceX prepares for Starship Mars missions. 33 Raptor engines on the Super Heavy booster, each with German turbopump principles from 1942. Elon Musk wants to settle 1 million people on Mars. With technology whose roots lie in Hitler's vengeance weapon. That's not provocation. That's documented history. The V-2 was a weapon of terror, killed thousands in London, was built by slave labor at Mittelwerk. 20,000 forced laborers died building the V-2, more deaths in construction than in deployment, one of the darkest episodes of World War II. But the technology itself was brilliant, amoral, but brilliant. And that duality makes the story so complex. Can you separate technology from its origin? Can you admire the V-2 turbopump without forgetting the dead? Douglas O'Regan argues, we must do both. We must acknowledge the technical achievement and understand the moral context. We must know that our modern spaceflight stands on the shoulders of forced laborers, literally. Von Braun knew about Mittelwerk. He was there. He saw the forced laborers, and he did nothing. After the war, he lied about it. Said he knew nothing, but documents prove it. He knew he was part of the system, and yet he became an American hero, father of American spaceflight, Time magazine cover, honors from presidents. Because his technology was more valuable than his past, cold, hard, realpolitik. The Soviets were more honest. They called it what it was. Utilization of German expertise for Soviet goals. No moral excuses, just pragmatic exploitation. The German engineers in Russia had no hero status. They were spoils of war, technology slaves for 10 years. Then some were allowed to return to Germany, others remained forever. And today, 2025, SpaceX engineers know the story. Blue Origin engineers know the story. They all studied spaceflight history. They all know von Braun. They all know about the V-2. But how many know about Mittelwerk? How many know about the 20,000 dead? How many know that their Raptor turbopumps are conceptually identical to machines built by slaves? Douglas O'Regan wants us to remember. Taking Nazi-era technology is not an anti-spaceflight book. It's a book about honest history, about acknowledging where our technology comes from, about understanding that progress often stands on dark foundations, about recognizing that the V-2 turbopump is simultaneously an engineering masterpiece and a symbol of slavery. Both are true. Both must be acknowledged. Technically speaking, the V-2 turbopump of 1942 was 20 years ahead of its time. No other country in 1942 had even a theoretical understanding of such systems. Germany built and flew them. In 1945, the Americans could not reproduce them, not until 1952, with German help. The Soviets needed until 1949 with German engineers. Without German expertise, the world might have waited until 1960 for functional, large turbopumps. Spaceflight history would have unfolded completely differently. Today, every large rocket flies with turbopumps. SpaceX Falcon 9 Merlin engine with a turbopump, Falcon Heavy, 9 Merlin engines, Starship, 33 Raptor engines. All turbopumps, all based on concepts from 1942. Blue Origin New Glenn, 7 BE-4 engines, all turbopumps. Ula Vulcan, 2 BE-4 engines, turbopumps. Ariane 6, Vulcain 2 engine, turbopump, European developed, but studies Saturn V. Studies F1, leads back to von Braun, leads back to V-2. The entire modern spaceflight industry, estimated value $500 billion in 2024, stands on the foundation of German turbopump technology from 1942. Every satellite in orbit was launched by a rocket with a turbopump. Every ISS supply mission, every Mars rover, every communication satellite, all indirectly used German technology. Starlink, 5,000 satellites in orbit, launched by Falcon 9 with Merlin turbopumps. GPS, global navigation, launched by rockets with turbopumps, weather satellites, Earth observation, communication. All turbopumps, all conceptually V-2 derivatives. The modern world functions on German rocket technology from 1942. We don't notice it, but it's true. When you use your smartphone today, use GPS navigation, watch satellite television, check weather forecasts. Thank the V-2 turbopump, indirectly, because without it, no large rockets. Without large rockets, no satellites. Without satellites, no modern communication. The V-2, built as a weapon of terror, accidentally enabled the modern information society. Irony of history, Elon Musk says. We're making life multiplanetary. We're going to Mars. The technology that makes that possible? German, 1942. Jeff Bezos says, millions of people will live and work in space. The engines that enable that. Based on V-2 concepts, NASA plans Artemis. Return to the Moon, SLS rocket, RS-25 engines, turbopumps, developed originally for the Space Shuttle. Space Shuttle engines are based on Saturn V and knowledge. Saturn V was von Braun. The chain is unbroken. China wants to put people on the Moon in 2030. Long March 10th rocket, YF-100 engines, turbopumps with German DNA. Russia plans new Angara rocket, RD-191 engine, descendant of RD-170, developed by Energomash, founded by German engineers after 1946. India plans Gaganyaan manned spaceflight, Vickers engine, French license, American roots, German concepts, every spacefaring nation, every private company, every new rocket, all use turbopumps, all use principles from 1942. The V-2 turbopump is the most successful rocket design in history, 83 years old, still relevant, still indispensable, still the basis of everything. And that is the story that taking Nazi-era technology tells. Not that Germany was good, but that Germany was undeniably a leader in some technologies, and that this leadership was stolen, systematically exploited, and became the foundation of American and Soviet power without moral reckoning, without recognition of the victims, without honest history. Until now, Douglas O'Regan opens the files, shows the documents, proves the technological lineage, from V-2 to Saturn V to Raptor, from Peenemünde Army Research Center to Huntsville to Hawthorne, from German engineers under Hitler to German engineers under NASA to modern engineers who apply German knowledge without knowing it. The V-2 turbopump invented everything. Not an exaggeration. Literally everything. Every modern turbopump concept comes directly or indirectly from it. Catalytic steam generation, pre-burner systems, cryogenic materials, high-speed balancing, regenerative cooling in turbopumps, staged combustion concepts. All developed in 1942 in Peenemünde Army Research Center, all still used in 2025. SpaceX Raptor uses German design today, not inspired by, not similar to, US's. The physics are the same, the problems are the same. The solutions are further developments of German solutions. Elon Musk might not phrase it that way, but technically, it's true. Raptor is the great-great-grandchild of the V-2 turbopump, better, more powerful, more advanced. But the genes are German. When you see the next SpaceX launch, remember, 33 Raptor engines, 33 turbopumps, all conceptually V-2 derivatives, all based on German engineering from 83 years ago, all enabled through Operation Paperclip, all built on the knowledge of Wernher von Braun and his team, all indirectly connected to the 20,000 dead. 10,000 dead at Mittelwerk. Technology is never neutral. History is never simple. Progress often comes from dark sources. But we can do both. Acknowledge the technical brilliance and remember the moral darkness. The V-2 turbopump was a masterpiece of German engineering. It was also part of a terror weapon built by slaves. Both truths exist simultaneously. Modern spaceflight owes everything to it. Modern spaceflight must also commemorate its victims. Douglas O'Regan says, "Taking Nazi-era technology isn't just historical appropriation, it's ongoing non-recognition. We use the technology, we profit from it. But we don't tell the whole story. We say American engineering took us to the moon. Technically false. German engineering, American resources, Soviet competition took us to the moon. That's honest. That's complete. That's the truth." November 25th, 2024. O'Regan's book is released. The National Interest asks, did Nazi military technology make the US military into a superpower? The answer, partially yes. Not only, but partially. Undeniably, V-2 rockets led to ICBMs, Me-262 jet turbines led to the F-86 Sabre, Type Sit U-boat technology led to modern submarines, German infrared optics led to modern targeting systems. The list goes on. Operation Paperclip wasn't just scientist recruitment, it was industrial technology appropriation. But of everything, the V-2 turbopump was the most influential because it enabled spaceflight, and spaceflight transformed the world. Satellites, GPS, communication, Earth observation, science, all dependent on rockets, all rockets dependent on turbopumps, all turbopumps ultimately dependent on German innovation in 1942. The story is clear, the documents are public. The technological lineage is provable. The V-2 turbopump invented everything in 1942. The SpaceX Raptor uses German design today, not metaphorically, literally. The fundamental principles, the physical concepts, the engineering solutions, all rooted in Peenemünde Army Research Center, all developed under von Braun, all stolen through Operation Paperclip, all form the basis of the $500 billion space industry today. That's the uncomfortable truth of spaceflight. That's the story that's rarely told. That's what Douglas O'Regan documents, and that's why it's important not to glorify Germany. Germany started a war of annihilation, committed genocide, enslaved millions. None of that can be forgotten. But technical truth cannot be forgotten either. German engineers made modern spaceflight possible under terrible circumstances, for terrible purposes, but technically brilliant. And today, we're flying to Mars with their technology. Today, we're building Starship with their concepts. Today, we're using turbopumps that are conceptually identical to machines from 1942. The irony is profound. The V-2, developed to destroy London, enabled humanity's dream of traveling to the stars. Technology knows no morality. People give it meaning. We decide what we use it for. Von Braun dreamed of spaceflight. He built terror weapons to finance his dream. After the war, he built moon rockets. Same man, same technology, different purpose. Can you admire him? Can you despise him? Maybe both. Moral clarity is difficult when it comes to complex history, but technical clarity is simple. The V-2 turbopump from 1942 was revolutionary. It enabled everything that came after. It's still used in modernized form. 83 years later, it's the most successful rocket subsystem in history, and it's German, undeniably, documented, provable. From Peenemünde to SpaceX, a direct line, 83 years, one story. Support this channel with super thanks. Enable more in-depth technical documentaries, more uncomfortable historical truths, More stories that are rarely told but need to be told. Click on Super Thanks under this video. Every amount helps. Every amount shows you value, honest history, technical accuracy, complete narratives, not simplified myths. The V-2 turbopump invented everything. SpaceX uses German design today. That's the technical truth. The moral truth is more complicated, but both truths must be told. Douglas O'Regan did it in his book. I'm doing it in this video. You spread it by sharing, commenting, discussing. History only lives when it's remembered. Technology has history. This history is important. Thank you for listening. Thank you for wanting to know the complete story. Not just hero myths, but reality. Complex, uncomfortable, but true. Write in the comments. Did you know about this technical connection between the V-2 and SpaceX? Does it surprise you that modern Raptor engines use German concepts from 1942? Do you think we should discuss this story more openly? Your opinion interests me. Honest discussion is important. History isn't black and white. Neither is technology. Let's talk about it here, in the comments. Civilized, fact-based, honest.